Hi all. I just wanted to go back and retouch on this drawing the graph. So let's look at this. So first we're going to, the bus is going to be at time is 0 seconds, velocity at 20 meters per second is slowed down to 20 seconds with 0 meters per second. So that is this part here. Let's see if I can draw on it. So from this point to this point is the first part. Now if we come back here up here to B, draw 20 seconds to 40 seconds. The bus's speed is 0 meters per second. Draw a horizontal line at speed is 0 meters per second from 20 seconds to 40 seconds. So that is actually right here, this bottom one here. Let's see if we can draw a line here. So from here to here. Okay, maybe you can just see that. Okay. All right, let's see if we can get back to this. Okay, that shows me this. Okay, now from 40 to 50 seconds, the bus accelerates at 1.5 meters per second. So we're going to draw a line. It first started at 0 meters per second, and then by the time it got to 50 seconds, it was going at 1.5 meters per second. So from here to here, okay, from there to there, to up here, you can see that it increased in speed. And then last, from 50 to 60, it's not going at 0. It's not stopped. It's just going at a constant speed. It's not accelerating, which means it's at 15 meters per second right here. This part right here, you can see that, okay? All right, now, let's look at number 9. Okay, suppose the bus's acceleration at 1 meter per second from 40 seconds to 50 seconds. So we're going to draw a line showing its acceleration, okay? So we should go from 0 meters here at 40 seconds to 50 meters at 10 seconds. So this is where we should have stopped. Let's see if I can go back and highlight. Let's close this. And let's see if it'll let me highlight this. So we should be highlighting, let's see, highlight. So we should be going from 40, we should be drawing a line up here, right up there, okay? That's where, for number 9. Okay, number 10, calculate. So let's go back to this one. Let's see if I can get back to my A. Okay, so calculate what would be the bus's speed at 50 seconds if the bus accelerated at 1.0 meters per second from 40 seconds to 50 seconds. So my acceleration would be 10 meters per second, okay? Okay, determining acceleration from distance versus time graphs. You've just seen that you can determine whether an object is accelerating by examining a graph of speed versus time. You can also identify acceleration by examining a graph of distance versus time. On a graph of distance versus time, a curved line indicates acceleration. For example, compare the two graphs in the figure below. They show the motion of a bicyclist in a race. So on this one, on a speed versus time graph, the bicyclist's motion is a straight line with a negative slope. Therefore, the bicyclist was slowing down with a constant acceleration, so slowing down at a constant speed. On this one, on a distance versus time graph, the bicyclist's motion is a curved line. The curve on it indicates that the bicycle was accelerating. So at this point, it wasn't going at a constant speed. It was actually accelerating here. Okay, so let's explain, is the bicycle speeding up or slowing down? What would our answer be? So if it was going, so let's look at this. I'm going to go back here and get my highlighter maybe. Okay, let's see if I can do this properly. I don't know if I can or not. So right here, so if we were to go in a constant, we would be going up like that, right? So that means it's accelerating at a constant speed. But look here, our curve did not follow the same path, correct? Okay, so we're going to write down what has happened. So it's indicating that the bicyclist was slowing down. You can tell, you can tell because the graph of speed versus time has a negative slope. Negative slope. That's this curve that I've shown you. Okay. And this is the end of part 2 of chapter 11.2. So go online on Infinite Campus and submit your homework. See you all tomorrow. Bye.